Okay, continuing our work now with rates of change, calculus, differentiation. We're just going to have a look at some different types of terms. So some terms specifically that involve negative or fractional powers. Okay, so what we've looked at so far, we've done lots of deriving. Apologies, just had an intruder. Okay, back to where we were talking. So we've been looking at yeah, we've been deriving and we're getting pretty good at it, hopefully. So now we're just going to have a look here. As you can see in this first example, we've got a negative power here. A bit later on in the show, we'll have a fractional power and square roots and stuff. So, all right, so we're just expanding our horizons a little bit, skilling ourselves up. So when differentiating terms with negative and fractional powers, the same principles apply. That is what we've got in red here. When we've got y equals x to the power of n, the excuse me, the derivative is n comes down the front, x to the n minus 1, reduce that by 1. No different here, no different. We're just going to, I guess because it's negative, they're negative powers and fractional powers there, they might be just a little trickier to work with, and we just need to be a bit more careful, but that's about it. Okay, so first example, let's do some examples. Find the derivative of y equals this. Alright, so I'm just going to mix up the notation as well. It says y equals here, it says f of x equals here. Remember when it says y equals, we just have to follow suit with y dash or dy dx. 4x to the 4, right, we're good with that, 4x cubed. Alright, here's a negative power. This minus 3 now comes down. So same deal, multiplies by the minus 2. So minus 3 times minus 2 gives us plus 6. Alright, now the x holds, that power goes to minus 4. Alright, now think about this term. Maybe if you can pause and do a couple of, you could do this example here, couldn't you? And you could probably do this one down here. Great idea to get ahead of the game and then play again and see if you're getting them right. That'd be a great use of this YouTube. Okay, so back in here with this x to the minus 1. Minus 1 comes down, so it'll be minus 1x, but I'm not going to write minus 1x because I'm in high school now. So minus x rather than minus 1x, and that minus 1 reduces by 1 to minus 2. And the plus 2, we don't bother with that, it goes to 0. So there's our derivative. There's our derivative function. We could, if we wished, rewrite it as with positive indices, but we're not going to worry about that. If you wanted to do that, and perhaps just a little recap as to how these things work, over here, I would write that as 4x cubed. No change there, but this 6x to the minus 4 plus 6 over x to the 4, isn't it? Minus 1 over x squared, and that's using positive indices. Okay, but I'm not going to do that with all the rest of the questions. We're just going to get used to deriving. Okay, f dash x. Get ahead of the game. See if you can do it. Pause me and try it out. Okay, so 2 times 3 is 6x. Brilliant. Minus 2 times minus 6 is plus 12x. Reduced by 1 minus 3. 1 disappears to nothing. There's my derivative function. Okay, example 3. Find the gradient of the curve at this point. So we're just going to take it one step further. I need to find the gradient of this curve. Whenever this word here pops up, gradient, you think derivative. Derivative. Alright, x squared. Oh, hang on a sec. This 1 over x, what's that? Actually, I need to get that in differentiable form, so I'm not ready yet to write f dash x. I'm still with my function of x squared plus, let's write this as a negative power, x to the minus 1. Hopefully that's not a challenge for you. So we now do f dash x equals 2 comes down, 2x, minus 1 comes down, minus x to the minus 2. And it might actually be easier now to write it as a positive index, so that we can put in this value of x here. Alright, find the gradient of the curve at x equals 1. This is my gradient function. At 1, it's 2 minus 1 over 1, isn't it? F dash 1 is equal to 2 minus 1, which equals 1. So therefore, gradient at 0.12 is 1. Okay, let's go down now. Question 4. This is a fractional power. So a fractional power, how does this work? Same idea. And I've got it in a nice format. I've got my coefficient, my base, my power, so I can get right into it here. I'm going to do y dx this just to mix it up. 2/3 times 4 is 8/3, isn't it? 2/3 times 4 is 8/3. Hopefully that's good. Just 2/3 times 4. Whenever I'm multiplying fractions, I just think of 4 over 1. 2 4s are 8, 3 1s are 3. Okay, that's useful. So 8/3 x. Now reduce this power by 1. Again, 2/3, I'm going to subtract 1. But rather than writing it as 1, I'm going to write it as 3/3. 2/3 minus 3/3 is the same as 2/3 minus 1. But this has got the benefit of me being able to work out that 2 minus 3 is minus 1. So minus 1/3 up here as my power. And that's my derivative. Okay, the last one we've got down here, it's not in differentiable form. A bit like this one up here where we had 1 over x. Got to get it in differentiable form. So before I derive it, I'm going to get it as x to the power of a half. So maybe just a little recap on indices here. Square roots mean half powers. Cube root of x would be x to the 1/3. Okay, but generally, x, the nth root of x to the power of m is equal to x to the power of m over n. Right, this is the root you're taking there, and that's the power if we've got one. So this is the cube root of x to the power of 1. Generally over here for negative powers, right, where are we? In here somewhere. Right, x to the power of minus m equals 1 over x to the power of m. It might be worth just writing those down, little recap on fractional index powers. Okay, so fractional and index powers, that didn't make sense. Fractional and negative powers. Okay, here we go. So we've rewritten this as x to the half. Now it's in a differentiable form. F dash x is equal to, half comes down, subtract 1 from a half, that's minus a half. So a half x to the minus a half. Okay, and that's our derivative. Alright, so I reckon now we're ready to go with 22a and 22c. Yeah, we're going to come back and do b, but 22a is negative powers, 22c is fractional powers. We're going to get some practice with those, look at the work requirements. I think that'll be good for us, and we need to really charge through that in class next time I see you. So I'll catch you then.